Can I have my slide, please? I'm waiting for my slide. Anytime we're ready. Nobody brought beers? There we go. I like this crowd over here. I once killed off a virtual server just to watch it die. Lightning is afraid to strike my data centers. When I swim in the ocean, dolphins always come out and join me. When they leave the toilet, women leave the seat up for me. I was abducted by aliens, and they asked me to probe them. I don't introduce technology panels very often at conferences, but when I do, I prefer RightScale. So stay cloudy, my friends. And if you're thirsty, we have plenty of Dos Equis. Thank you. So now let me introduce the future of applications in the cloud panel. And speakers, please come out as I introduce you. Steve Martin is the general manager of the servers and tool business for Microsoft. And in that capacity, he manages the Windows Azure business and operations organizations. Steve, please come out. He focuses, please hold the applause till the end because I'm going to introduce a few people. He focuses on long-term business strategy and capacity planning and operations for all Windows Azure services. Next up, and Brian Goldfarb, please come out. Brian Goldfarb is the head of cloud platform marketing for Google. No, wait. Let me just introduce everybody. He's responsible for global marketing and business strategy for Google Cloud Platforms, including the Google App Engine, Google Compute Engine, cloud storage, and a lot of other services that fall into that rubric. Next is Roger Levy. Please come out. He's the vice president and general manager of Hewlett-Packard Cloud Services, and he's responsible for driving Hewlett-Packard's public cloud business, including product development, research and development, sales, business development, and marketing. And now Duke Skarda, as CTO of SoftLayer, he holds responsibilities for designing, implementing, and enhancing the SoftLayer infrastructure management platform. And now I'm going to bring out our moderator. You might have seen him in the keynote earlier today. He also had a very interesting breakout session. James Staten, he's the VP and principal analyst of Forrester Research. Please come out and take it away, my friend.
Thanks.
All right.
Thanks to all of you. Thanks to all of you coming in and being part of this session. This is not meant to be 5 guys on a stage having a conversation. This is meant to be 150 people asking these 4 guys to sweat. So think about your questions, jump in. I'm going to be looking down here. We've got people down here with mics who are going to be looking for your hands to go up. If you object to something, please jump in. We want to hear your thoughts because you're going to build the applications that run on all of these cloud platforms. You've already heard the introductions from them. You know the topic. So let's get right into it about what are the kinds of applications that we are seeing in the cloud. And Stephen, I want to start with you. In Windows Azure, what is the trend? What are the kinds of applications that are coming into this cloud?
Sure. So we started our journey a couple of years ago, as you guys know, and we focused on PaaS services. So the majority of things that we see in the cloud are net new development, focused largely on customer-facing web-based scenarios, is the primary use case.
Okay, Brian, anything different in yours?
I think there's very much a similar origin from the Google Cloud Platform, kind of coming out of the App Engine world, which was a PaaS solution. I think one of the areas on the consumer-facing side, though, we see some differences is a lot of mobile and gaming applications. Kind of lean-forward developers, cloud-oriented, that are taking advantage of cloud services to start their business and being able to leverage a lot of Google's broader assets at the same time. So I think that's the kind of the application trend that we're seeing.
Okay. And both of you started mostly with a public cloud. There was just public cloud.
That's
Roger,
correct.
Obviously you've come from the enterprise side. You've started with professional services, and professional services is the group that launched the HP cloud. So is it different there, or is it mostly?
No, it is different, and I think part of it is also our orientation to more enterprise-grade enterprise IT. We do see a lot of new build, line of business, websites, mobile applications, but we also see backup, disaster recovery, archival, working with a large number of various applications that today are running in private to allow them to run hybrid between private and public. Just a broad range of, if you are certified within a Linux environment, we also support Windows. If you're certified in a Windows environment, a large number of apps from the enterprise moving to the cloud, not necessarily permanently, but as part of the overall hybrid strategy.
And Duke, SoftLayer has been a hoster and a managed service provider for quite some time. So what's the split between what goes on to cloud versus what goes on to traditional hosting?
Well, traditional hosting has really changed a lot over the last several years. And our product line really consists of what we call bare metal compute and our public cloud. And our customer base is really consists of companies whose entire lifespan and life cycle is existing entirely on the internet. The internet is really their production facility, if you will. They acquire customers and they deliver all their products over the internet. So our platform is really geared for customers that have a global scale. They can leverage a private network for really quick transfer of files on the back end, and bare metal compute where they can design a system that is built for their workloads and their performance requirements.
So let's talk a little bit about performance since you brought that up, because a lot of customers we talk to, if they got a really performance-centric application, they say, I can't put that in the cloud. I can't even virtualize it. It's got to have its own machine. Brian, your service has gotten a lot of attention for being performance-centric. Is that true, or is there parts of it that are not?
I think it's definitely true. I'm sure there's truth to both sides of the story. But when we look at what Google has done with our cloud platform, it's taking 14 years of Google infrastructure investment in powering global class services like Gmail and YouTube that are some of the most compute and bandwidth intensive applications in the world, and running those. And we're taking those APIs and those systems and exposing them for anyone to use with a common set of API architectures. And the good news there is we can run Google, and so we're pretty confident that we can run anything. And what we've seen lately is not just performance being important, but consistency of that performance. It's very easy sometimes to get a high-performance system, but making sure you're always having a high-performance system and it's consistently delivering the performance that you expect. And that, by having that kind of Google core at the back end, is what we're seeing that common in our kind of the HPC scenarios and broader workloads.
And certainly we're seeing performances, oftentimes application specific. If I'm doing video codecs, that might be totally different than if I'm doing a mobile application where, frankly, the network to the mobile phone is going to be where performance gets determined. Stephen, obviously, you've done a lot with customers in the video space. You obviously have a mobile backend as a service you launched recently, and you've had web services before. So you're delivering services on top of infrastructure as a service that may not necessarily just be the PaaS, but they may be a little blend of what's in between. Why are you doing that? Why isn't everything just moving up to platform as a service?
Well, it could be a variety of reasons. And at first, I think it's important to point out Microsoft participates in the cloud world in a couple of ways. One, directly with Azure, and then one as a supplier of technology to organizations like HP and to Amazon and to a Rackspace and a variety of others that use Windows Server and build big chunks of their business on top of that piece of technology. For the Azure piece specifically that you mentioned, it's probably best to give a specific customer example. So NBC will broadcast the Summer Olympics next year using Windows Azure. So they're making a bet on us for network, for compute, for codecs, for distribution, for a variety of things. And we think it's a great customer-facing scenario, making a deep bet on our network capability and our ability to encode over 5,000 hours of video.
And Roger, you have a lot of customers in a lot of different specialized areas who come to you because you have expertise. Like I know a lot of transportation, particularly airlines, come to HP because you've built things specifically for them. So what's your philosophy? What kind of applications do you expect to capture a greater share of than the other clouds, and why?
So, I mean, one of the things that we really expect to capture, and we're already seeing it, is those that require more customization. I mean, we've got a good number of customers, people who are in business intelligence, analytics, and other areas, need very finely tuned instances. A specific combination of CPU, memory, I/O, need it done in a particular way. One of the good things about the approach we've taken with OpenStack is it is open, it is transparent, and we work with our customers down at the very detailed level, at the code level, to really help them optimize. So I think that has really attracted some of the tougher performance areas, including some very heavy analytics workloads.
And Duke, the blending of the bare metal and cloud, are these two separate worlds that aren't going to meet?
Oh no, they've already met. We put both of those products behind the same API set, behind the same portal, management portal, and they're all attached to the same network on the back end. So a customer in our world can move back and forth between bare metal and our cloud instances natively. We have the ability to capture an image in the cloud world, in the public cloud, and deploy it to a bare metal instance and vice versa. So you can really move between them natively. So it allows a customer to start small and expand as their platform grows. It allows them to change their architecture over time, to move from a small box to begin with to a very large single tenant box. So there's a lot of flexibility, and that's why we really look at both of those as being just two aspects of the cloud.
Okay, great. What questions do you guys have for the panelists up here? What kind of workloads are you trying to bring to the cloud? Are you struggling with? Or do you think, frankly, I could never move these to the cloud? Go ahead and throw your hand up if you got a question for these guys. And if you touch your nose, we're going to grab you.
So I feel like we've made good progress on workload mobility, but what about data mobility? I feel like that's still a struggle.
Good question. Who wants to take that one first?
Yeah, I don't mind. Data mobility is a big issue. There's a few things we struggle with. There's the abject reality of the speed of light, which is something that, to the best of my knowledge, we're not going to change anytime soon. So as we think about planning data centers and making sure that we're proximal to customers, that's one issue that we deal with. The other thing that we find a lot is the ingress of data to get a customer to a starting point is a really big issue, particularly when you're talking about petabytes of data having to be moved before you can take action. And then the economic value of that scenario, if you have to move big petabytes of data and it's a short run scenario, it's probably it's not gonna make a lot of economic sense if it's short run. So we find in a lot of those scenarios it may be best to go with an on-premises environment to allow for the customer to do what they do. In fact, in many scenarios, we find you don't necessarily need the data to get the richness of the application that you're delivering. What we do know is that pipes will get bigger, right? They absolutely will get bigger. Throughput will continue to improve. Data center proximity will continue to improve. But there are certain scenarios, particularly when you're talking about a time-bound event, where the size of the data block, given what you need to do, will butt up against practical realities for the economic benefit that you'll see.
And Roger, you brought up disaster recovery. That's movement of data. So are customers actually overcoming that?
There are a number of ways. I mean, again, it is very workload specific. But if you look at what's going on, I mean, we have essentially bulk upload capabilities, direct connect capabilities between data centers and the cloud, and other technologies. So it is definitely an issue. I think, as with many things, the feature functionality that's being introduced by HP and across the cloud industry is starting to, really address it. Some of our customers, DreamWorks, probably a great example. They generate a tremendous amount of data, as part of rendering animation. So along with Panzura, they have local store within their data center. They use Panzura devices for intelligent caching and movement, and we, provide the object store within the cloud and integrate all that together for them, so they can get the best economics possible as they're working on rendering. Things that are not being worked on right at the moment can go to the cloud, brought back, rendered, and moved back and forth very efficiently.
Duke?
Yeah, that's a good question. That's one of the drivers behind our private backbone that I mentioned a moment ago. A lot of our customers leverage a lot of the new NoSQL databases that natively live in multiple data centers at one time. And one of the problems that we experienced with public cloud, ours as well, when they were going through the public internet to synchronize data across data centers, is there's very unreliable, ping times, those connectivity times would bounce up and down. So when we built our backbone network, that was one of the real drivers, is to streamline the ability for those, MongoDB or React, a lot of the Couch-based products that natively know how to live in multiple data centers across WANs, for them to be able to synchronize very efficiently and effectively. So I think we're making progress. It is difficult to ingest a couple of petabytes. That's just a problem that it's going to take a while for us to figure out how to do that quickly. And today, in a lot of cases, we end up shipping a drive or shipping on an entire SAN to one of our sites to seed the data.
So I'll just back up a truck and send you my drive, right? And that'll be enough, right?
You think we'll take a truck? I think one thing to add, and there's definitely challenges on the ingest side, but once you're in the cloud, one area where we put a lot of energy is in the Google infrastructure. We laid our own transatlantic cables to make sure our network connectivity from point A to point B is almost instantaneous. Moving VMs from the US to Europe can happen very quickly. So data mobility can be solved through very, very advanced networking solutions inside of a single cloud provider. And I think for a lot of scenarios, you said workload specific, but for a lot of scenarios, that is the problem on data portability, and that's solvable. Google solved it for itself. We'll solve it for you. But the ingest piece, as everyone mentioned, certainly the biggest front-end challenge.
Next one for you to work on is the speed of light, right?
It's actually we're working on it. Google X team is this close. After class, first class.
Go ahead.
Hey, one of the things that was brought up this morning in the keynote was the concept of multi-cloud, which RightScale, I think, has been at the forefront of espousing in this industry. What are your guys' stance on that? And would you foresee a scenario where you might joint sale with someone sitting next to you for a large cloud, for a large account that might want that to get better HA across multiple clouds?
Go ahead, Brian.
Yeah, I think we're sitting at a conference with a company that is helping pioneer the ability for companies to build multi-cloud solutions. And from a Google's perspective, we want to be part of a multi-cloud environment. And whether you're running on HP and Google or in a private data center in Google, there's lots of reasons why you'd want to be in multiple places. And there's no reason that we wouldn't want to be part of that solution, whether it's going to market with a partner and or a competitor in order to win your business.
But how are you going to enable that? I mean, Roger, you want to go first on that one? Obviously, you're on OpenStack and Open Standard and Open Approach. Is that the layer? Is that where this will make it easy?
That's part of it. It allows for the interoperability to be able to pick up, workloads, migrate them, to be able to, have the elasticity and scale across clouds. But there's still work to do. There's work around, identity federation. How do we actually do all this, with ease of use, federating identities between clouds? It is coming. I mean, the other piece of it, while it's not necessarily between different public providers, I mean, we're doing a lot of this today between public and private within the same, vein, being able to take our customers' private cloud and, going back and forth in intelligent ways. We're also in discussion with, other service providers about how to do it. And then there's one other, interesting thing. We're working with a number of service providers to actually build their public cloud, which is somewhat competitive, but it's an interesting world. If we know exactly how their cloud works and it works exactly like ours, it makes the problem very easy.
Duke, you obviously connect data centers on a regular basis. I'm sure you have connections to customers' enterprises. So is this different? Is having a workload that can move from your clouds to Roger's, to Brian's, to Stephen's different than a workload running on-premise moving into SoftLayer?
Well, there's every situation is different. And whenever we run into customers who are really thinking about a multi-cloud solution, private, on-premise and off-premise solution, what we try to talk them through is really leveraging the right resource for the right problem. Mm-hmm. Solve the problem you're trying to solve with the best solution, and not go with a multi-cloud solution just to have multiple clouds. Mm-hmm. But what problem are you trying to solve by going multi-cloud? Are you trying to multi-source? Are you trying to leverage Google Compute for what it does best, SoftLayer for what it does best? Get your storage somewhere else on premise. There's a lot of different things you can do with these tools, and the key in all of it is to architect your system. Back in the 80s, 90s, early 2000s, there were architecture teams at enterprises, and they're still around. But as an industry, we've kind of gone away from architecting systems, and we've gone to here are the tools. What am I going to do with them? And what we try to talk our customers through is take the time to think through what you're doing, how each layer in your application should work, and then architect accordingly. What are the tools? You've got a lot of cool tools now. Yeah. How do you want to bring those to bear?
Yeah, that makes sense. Other questions?
Hi. Any of you think that pricing per unit for any of the cloud services will ever stop declining, and if so, when?
In other words, are any of you going to be profitable?
I'll take it. No.
No.
It's not.
No.
It's not going to stop declining.
Nope.
That Moore guy was pretty smart. And
Moore's law is true.
and that will continue to be the reality. And as long as we're continuing to crank out technology and improve on the speed with which we're able to flop bits, some of that value will go back to customers. Customers are going to be the big winner in this deal. And we last week announced that we were going to match Amazon on commodity services like compute, storage, and bandwidth. We're going to take that issue off the table. We feel very strongly about that. There's a lot of higher value services that we'll also offer as well, but we feel great about returning the value to customers as prices continue to decline. It's great for things like storage. I mean, gosh, see what we've done in the storage market over the last few years, right? We're down to what, 5.5 cents at volume for a gig of storage per month. I mean, based on that, it's going to be really, really hard for folks to sell high-end storage solutions when you get that kind of price in the cloud.
You can do that while breaking even, or this is a loss leader for the other things?
Well,
welcome other comments too.
What I'll say is that our ability to make money or lose money is not part of the equation. The market determines value, right? And then how well we execute against that to do so efficiently determines if we have a good business or a bad business. But the market determines the value. And we're not here to tell you what the value is. The market determines what the value is, and we're here to play in that market.
But how do you drive it while being profitable at the same time? Because you can't just keep responding to Amazon's price cuts. You got to make changes to your architecture that allow you to cut the price first, where you maintain a higher profitability and put the other person in a world of hurt trying to match that.
Well, and there's places where we do that. And there's places like we were the first company to cut transaction prices way down. And there's lots of places where we're going to try to take the variability out. We were the first company to cut ingress to zero, right? Make that free, and we'll continue to look at opportunities to lead the market and push on that side. But we want to make sure that no one feels like there's some short-term economic gain by one or the other, at least between us. And so we're going to try to neutralize that particular argument. We're going to do what we do best: very, very, very high volume, low cost. And we'll continue to do that, and we'll get great at it. This isn't a side business for Microsoft, right? I mean, this is our future. This is the future of our ability to participate in the compute world. There is no business to fall back to. We will get good at this. Margins will improve, and we're gonna deliver first-class products to the market because of that.
Duke, how's SoftLayer going to win this?
Well, there's a lot of angles to that, and I think the straight answer, as he said, is no. The prices aren't going to stop dropping, but pricing in the cloud. Just like pricing a little bit on your own laptop when you're shopping around, it's not everything is one for one, right? There are a lot of complexities in pricing what a compute unit is, what kind of performance are you getting. To get a truly performance system is going to involve a lot of add-ons with your typical cloud service. So we look at pricing as really a performance issue and a value issue. So there's low-end stuff, and I think at that level, those prices are going to plummet, and they just will over time. But then there are high-performance solutions, and those prices will go down over time. But as an application scales from starting out in the low end, starting out small, and as they move up, looking at other options and looking at ways to scale your application is very important. On our side, we're always looking at ways to scale our data center and ways to scale our operations and further automate. And those two things will just continue with time, along with just the raw price of storage, RAM, and CPUs going down over time. It won't stop anytime soon.
Other questions? Yep.
Yeah, hi. So my question is, so virtualization has kind of almost disconnected us from the hardware. And this kind of, that lag is increasing, right? So let's say Intel or any other chip maker launches a chip in this quarter. That chip will get into the cloud maybe a year later, or maybe, I mean, I don't know the exact number, but it does not appear immediately, right? That's the kind of for high performance applications which we have optimized for a specific chipset, or when we kind of work with the chip maker for a chipset, now it gets very hard to kind of port those applications on the cloud.
That's exactly why why we take a two-prong approach in our cloud. We work actually with Intel, and we often have chipsets from Intel in our data centers before they're publicly available. And we make those available to our customers through our bare metal product line. So when you get to that level where you're interested in the chipset, we have a product line that does that. On a public multi-tenant cloud, that's about scale and about us being able to spread costs over a large number of servers. And it does take a long time for you to experience the chipset or for you to even find it, because at that point, it's one of a lot of compute resources in our pool, and you may or may not be assigned to that one. So that's why we take that two-prong for exactly that reason.
And I think your question is a little bit broader as well.
Yeah, I mean, so since we're talking about future here, right? I mean, I know what we do currently, but this two-pronged approach is maybe not the best approach for the customer, right?
No, I think that's exactly my point. Is if you want the latest chipset, you can go to our website and you can select that exact chipset, and you get it the day it's released. We've done that for the last 7 years, and we'll continue to do that. So you have the power to select that if you go down the bare metal path. If you want to be in a multi-tenant cloud and you're okay, with being spread over a large pool of resources, that's what a public cloud is all about.
No, I'm trying to indicate something else, something more deeper, right? I mean, so if I see offerings from Google Compute or Amazon or Azure, I mean, how are they classified? Machines are classified with, two virtual cores, this much RAM, and this much disk capacity, right? Now, all the hardware details is kind of hidden. What frequency are they running? If I take one instance on Google Compute, it's similar looking instance on Amazon. On surface or on the text, they look same, but when I run my application on both of them, the performance is like widely different. Within Amazon, if I run my application on two M1.large instances, one instance I get with a different clock frequency, I get a different instance with a different clock frequency.
Yes.
Right? Now, how do we converge on that, right? I mean, so, okay.
Well, let me have 30 more seconds, and I'll take one more crack at the bare metal, and then I'll let these guys answer. To explain what I mean by bare metal cloud, it's a single tenant server that you get turned up and you manage like a cloud server. But you select the hardware. You select the chipset. You select how much memory goes on there. You can select how many drives, what types of disk drives, SATA drives, SSD, 4 of them, 36 of them, 200 gig, 800 gig, 4 terabyte. You select that. You build that. It's your box. You can select the latest chipset. That's a bare metal cloud. In a public cloud, which SoftLayer has and all of us have, you don't have that specific abilities to select the chipset. And the problem you're bringing up is true, and that's why I'm saying we take both approaches. We deliver a bare metal cloud to give you the ability to select exactly that chipset if you want that. A lot of customers don't need that specific power, but that ability exists in our bare metal cloud. I'll turn it over to others.
Your question is spot on. It's spot on. This is something that's been plaguing us for a while. We've tried to be really transparent about publishing the spec for the underlying thing, for the equivalent, and providing a relatively homogeneous experience. Like a core in Western Europe versus North Central is going to run the same in our environment, which is different. But your point is right on. And I think over time, there's going to be push for more transparency on exactly what it is that they're running. We're starting to do that a little bit. We're demarcating generations of compute that are going in and starting to publish a little more detail. And we see Amazon doing that as well. I think the next point to your question, which I also agree with, is there will be a race. Like the next race will be how fast can public cloud providers get the cutting edge chip designs into systems and make them available at scale for customers. So if anybody wants to prognosticate like the next wave of really, really intense competition, it's going to be speed to market for some of those faster end chips and for big availability. But I'm completely with you. I think the industry as a whole has not done enough to be transparent enough about what's running under the covers. And I couldn't thank you more for your question, and keep pushing. And we'll keep pushing as well.
Go ahead, Roger.
I think transparency is a great point. We have worked with many of our customers to give them the exact bill of materials for the racks that their services work on, and I think that is something that we continue to do as part of our program of transparency. And working with our customers to optimize. On the latter point, though, of speeding new chip innovation and hardware innovation into public cloud, kind of a topic near and dear to my heart. As being the world's #1 IT vendor, I'm my own supply chain. We have as you might imagine, quite a good relationship with Intel, between Intel and HP. And with innovations like the new Moonshot server, which has essentially plug-in personality modules, we're designing a strategy as well as a supply chain so that we will be able to get the best, as well as influence the best, and get the best technology, get the best chips. And it goes beyond Intel, and it goes beyond the chipset into the public cloud. And that's something that we're very passionate about.
Question. Who's got another one? Yep.
I think what you guys are saying is true for a lot of applications, but I do scalable web APIs and stuff, and honestly, I really don't care what's going on under the hood at all. I think a lot of the idea behind cloud is that you don't have to worry about that kind of stuff. And so for some applications, you might care what your particular chipset is or how many clock cycles and stuff. But for me, I'm just talking how many requests per second can a server handle. And it doesn't matter if they're using the latest Intel chipset or if it's 10 Raspberry Pis hooked up together. I don't care either way.
I think that goes right to the topic of this panel, which is the future of apps. So how much is this going to matter? I mean, Brian, you've got people that work at the abstracted level all the time.
And I think you always get to this question when we talk about cloud is it always depends, right? The answer is always, if you have a question, it depends. It depends on what your workload is, depends on what you're trying to do, depends on what the class of customer is. Your case is incredibly common where we see that is becoming the vast majority of applications that are being run. No one cares about the underlying characteristics. They care about the performance, they care about the cost, and they care about the consistency. And they care about the ability to respond to the customer needs at any moment in time from a scale perspective. And with Google's cloud platform, with App Engine in particular, as applications get built and deployed there, no one thinks at all about any of the infrastructure layers. They're focused on their business logic, their solution, with the knowledge that whether they're a 0 customer solution or a 10 million customer solution, Google will take care of all of those details on your behalf, because that's time that you shouldn't have to spend. And I think for that class of applications, the world is moving to a place where people aren't going to think about the architectures or how the data is stored. It's just, it must work well, and it must be available and fast and respond to customer demand. Now, on the other side of the coin, particularly for large enterprises where I think where HP is delivering a lot of value, is how do I get these customized solutions? And on the compute side of what we're doing, I think what everybody's doing is how do you have transparency? How do you provide flexibility so that those applications can run? And the secret sauce is how do you make that work together so you can do both at the same time or neither? Because everyone's case is unique. And I think that's where you're going to see not just the next war, but the next application world is these not hybrid as in public-private, but hybrid as in how do I combine infrastructure and PaaS? Those top steps are going to disappear. You're not going to think about it that way. You're just going to build applications, and you're going to pool the resources required as you need them, depending on your specific scenarios.
Like a lot of these guys have had the opportunity to talk to lots of customers every day. And it's while the world is in black and white, generally within the first 45 seconds of the conversation, I can separate which way we're going to go into one of two buckets. There's a class of folks that talk about cloud where it's really about economics. Right? It's about, I used to buy a server, and now I rent my capacity. And in that side, I know I'm about to get a lot of conversation about what's the clock speed, what's the capacity, what's the RAM configuration. There's a lot of that. And then there's another class of conversation we have, which is more like the question that you asked, which is, I'm trying to build something in a radically different way. Quite frankly, I don't care what the underpinnings are. I want good value, good throughput for what I'm doing. That's more of a cloud architecture statement. I think most of what's been written over the last couple of years about cloud, if you really are critical and go through and look at the press, has been on the economic side. It's just changing the way that we pay for IT, right? I agree with Brian that the future is more in the latter, right? Doing new things that you couldn't do before or were hard to, where the economics of the server from yesterday, the server tomorrow matter far less to you than getting the job done with great value.
We got one last question here.
Just to clarify, my point was not in the transparency. I mean, so let me put it very simple, right? So I basically take two instances of some name is XYZ, right? Two instances XYZ, and they claim some numbers, right? If they claim that number, give me that number, because it's for me it's easy, right? I don't care. I really don't care if those two instances behave exactly the same way. But look at it from the economics point of view. How the cloud is built. Cloud is built to share, basically, right? It's equivalent to a carpool or something, right? So the moment you basically pool it, right? You share it. You're stepping on each other, basically, right? So
I hear this from customers constantly, particularly recently, where they're getting inconsistent performance from XX and of the same. They ask for XX, they get 3 XXs, and they behave completely different. I heard someone at the conference call it the catch and release tactics. You have to check it and then get rid of it. I think Hunter deserves credit for that. But one of the things that we're putting tons of energy into is that problem goes away. That the sheer capability of Google's network can provide the consistency of performance, so that when it says you're going to get it every time. I think that is what you're looking for, and a lot of that comes down to the capability and the architectures of the infrastructure that the cloud providers are building, and I feel very good about ours.
I think what I'm taking away from listening to this is diversity. I mean, we sort of think about the cloud as this sort of vanilla answer, and it's not a vanilla answer. There's hardware that you get. There's performance you get guaranteed. There's variance in the technologies, and there's variance in the services and the level of those services that are brought forth. So let's wrap up on what would be the one thing that you would want this audience to leave with about the future of apps in the cloud. What's going to be the big difference they should really start planning for or architecting for going forward? Duke?
Yeah, I think to your point there, I think the key thing that I always try to tell our customers is sort of to your point, is to know what you're trying to do. Whether you care about getting exactly what you requested, whether you have a specific set of requirements you're trying to meet, or you don't care at all. Whatever end of that spectrum you're on, find the solution that's going to meet that need, and then use that for that level of your application. All applications are different. It depends, right, is always the answer. And even within an application, the right way to solve a problem may be different, depending on whether it's a web server, a database server, transcoder. All those things are very different. So know the tool sets, know your problem, and then map the right solution to the right problem.
Roger?
I think we've been saying it, and that is the cloud should not be the great homogenizer of applications. Applications are different. They have different needs, different attributes. We should offer the ability to optimize your workload to the cloud. And quite frankly, in the future, and I think there's some interesting work going on in this area already, the cloud should help do that itself. With the app you have, understanding it, understanding what your performance requirements are, I/O requirements, ... speed of which you need to spin up 700 VMs and tear them down, and actually automatically help you do that optimization within the cloud.
Brian?
I'm going to be a little contrarian. I think if you go into the future, it's hard to say when that future is, 5 years, 20 years, 50 years. The apps are going to be fundamentally different than every workload that you have today. And they're all going to be built using a new architectural model and taking advantage of compute resources in different ways than the systems that we see right now. And that is I think, a deterministic fact of the future. And what we're trying to do with Google's effort is make sure that we can service some of the needs of today while helping application developers and applications themselves get to that point as fast as possible, because that's where you're going to get the most value. That's where you're going to get the best availability. That's where you're going to have the most performance. That's where you're ultimately going to be able to build the best solutions for your customers, not the way we're seeing it done now.
Stephen, you get final word.
Yeah, I would say think about what it is you want. I know that sounds basic and trite, but do you want an evolution or do you want a revolution? If you want an evolution, then stick with the current model of the IT rental, and we'll have deep conversations about economics, right? If you want a revolution, you want to build applications in a brand new way, we can help you do that, and that's the thing. But understand, somebody's ox is going to get gored, right? Revolutions, somebody's ox is going to get gored. There's going to be pain and churn along that journey. And so be intentional about your approach. Are you really just trying to change the way you pay for it? Or you want to build a new thing fundamentally in a very, very, very different way? And understand, a revolution does not have evolutionary consequences, right? There's bloodshed, right? So understand what it is that you want, be intentional about it, and drive that.
Awesome. Now I'm totally pumped to go watch Game of Thrones tonight because it's just fitting right in with that. Gentlemen, thank you so much for your time and attention. Thank for all of you. And we'll be back with another panel in a few minutes. That's it. I'll sit down.